Hello, and welcome to week 2 of statistics. Woo! Today we're going to be covering measurements, so how we measure different things using statistics, different types of categorization to how we classify variables. Last week we talked about statistics in a nutshell, so we had descriptive statistics, inferential statistics. Again, descriptive being more so what you're wearing. Today I'm wearing a flowery Hawaiian-esque shirt. Inferential statistics being more in depth, so my personality, am I an asshole or not? But essentially that was kind of the main gist, as well as the different research methods or designs that we have. So there was that in the correlational, quasi, and the experimental methods. So today we're going to get into measurement. We have reasons why we actually do this. So why do we measure variables in statistics? It seems like a silly question, but it needs to be asked to, move forward. So it allows us to organize our data. It allows us to organize our data into different ways to make this analysis easier. So if we know what kind of variables we're working with, we know what kind of statistical tests that we can use, because certain inferential tests that we have require the use of only these kinds of variables, or if you have one of each, it's going to be a different test than if you have two of the same kind. And we'll get more into that as we move forward in the semester. But for now, just know that it allows us to organize our data so we can make our analyses easier. And it allows us to separate our apples from our oranges, our groups of people that are psychology majors from the average number of animals they have in their household or whatever. Those are two different types of variables. But first, we're going to start with scales of measurement. So what this means is that since we use, statistics we think of as math and using a lot of numbers. However, different scales of measurement, we use numbers in different ways. So we have 4 of them. We have nominal scales of measurement, ordinal, interval, and ratio. Each of these uses numbers in a different way, and I'm going to explain more in depth and as to what each of these types of variables entail. So first we have nominal. This is used as a way to identify. So if we use numbers with a nominal scale of measurement, it is more so using numbers to identify something as opposed to giving it a specific value, and that value meaning something. So having the numbers don't necessarily matter in terms of having a larger or smaller number doesn't make any difference in terms of identification. So some common examples of nominal intervals are your credit card number or your debit number, your VIN, your vehicle identification number, your social security number. These numbers, if your social security number happens to be larger than someone else's, that doesn't make you any more or less important. It really doesn't make any difference. It's just how you are, how the state of California and the country of the United States identifies you by your social security number. Same thing with credit card numbers or VINs. You don't really, if your VIN is higher or lower than someone else's, doesn't really make a difference. It's more used as a way to identify, oh, this is your 1999 Toyota Corolla or whatever, or this is your credit card that you have with MasterCard or whatever. It doesn't really make a difference. So these numbers are not used so much as, oh, find the average of your social security number. Like, okay, no, it's just used to identify you. You don't really need to find the averages of these numbers because they're not really used in that sort of fashion. So nominal scales are also used oftentimes for coding. So we can change things into nominal variables or nominal scales of measurement can be changed into numbers if they weren't already. So when we have a data set, let's say we create a survey and we export the data onto Excel, and Excel just spits out all the information. Let's say we ask questions about people's marital status, their gender, and their ethnicity. Well, we can keep that. When we first download it from Excel, it can say, oh, man, Latinx, single, woman, white, married, down the line, et cetera, et cetera. But we can change that to be coded into numbers. So man is represented by 1 here, woman is 2, African American is 1, Asian American is 2, Latinx is 3, et cetera, et cetera. So nominal variables can start at nominal scales of measurement can start by being the actual title. So single, married, divorced, and they can be translated into numbers, and it still represents an identification. This is still a man who is Latino and they are single, etc. That's still identifying them as being of a particular group. So moving on to ordinal scales. So this conveys value as greater or lesser than another. However, these distances between are not equal. So some examples could be a place in a race. If you're running a mile, let's say, and you get first place and you run a mile in 7 minutes, something that I will never accomplish in my lifetime. But let's say that you run a mile in 7 minutes. Second place, maybe they're right behind you. They come in at 7 minutes and 2 seconds. Ordinal scales is saying that, okay, third place doesn't have to come in at 7 minutes and 4 seconds because the distances between the ranks aren't equal. So sure, first place was 7 minutes, second place was 7 minutes and 2 seconds. Third place can come in at 8 minutes. Maybe he just started slacking off and he was just like, oh, whatever. Maybe he had a Charlie horse or something. I don't know fitness, but ordinal scales, the distances between these ranks of first, second, third don't have to be equal. They don't necessarily have to be 2 seconds between each. It's more so just how it fits. Same thing if I were to ask you to rank your favorite soft drinks or your favorite movies or whatever. Maybe your all-time favorite soft drink is cherry vanilla Coke from Fat Jack's, which, rest in peace, Fat Jack's does not exist anymore. That's my favorite. I'm gonna have to find a new fountain soda place that does that mixture just right. But my all-time favorite soda of all time is cherry vanilla Coke from Fat Jack's. That's like top of the scale. Second favorite is just regular Coca-Cola. Third, maybe cherry Coke. Fourth is Dr. Pepper. However, the difference between, how much I love cherry vanilla from Fat Jack's, RIP, is like up at the freaking top. And then Coke is still good, but there's certainly a distance between them. There's not necessarily an equal number of, ranks between them or different numbers between them. It's not like, all-time favorite, next all-time favorite. There's not really a clear distinction of what that distance between them is. But again, the easiest way for me to think about ordinal scales is through places in a race where, first comes in 7 minutes, second might come in at 7 minutes and 2 seconds, and then third doesn't necessarily have to be coming in at 7 minutes and 4 seconds. So the difference between these ranks is not necessarily equal with 2 seconds between them. Another example that we can think of when we're looking at differences between ranks in ordinal scales, is looking at the most liked photos on Instagram. Now I've updated this as of about a week or two ago, so they might be changed by the time you see this. But for the most part, I did my extensive research, and the egg is still the top slot. The egg is still number one at about 54 million likes. No, you're good. It's at about 54 million likes. Next, we have the second most liked photo at 18.6, and the third is 18.4. Notice that these first, second, and third most liked photos, they are not equal distant. So obviously, the egg has more than twice as many likes as the second most liked photo on Instagram. And then that third photo, there's only about 200,000 between them. Or between second and third is about 200,000 people or 200,000 likes. Ordinal scales is saying, hey, these distances between first, second, and third don't have to be equal. It's just how it is. The most liked, second most, and third most liked, they're not necessarily a specific, has to be the same size or the same distance between first, second, and third, and fourth, and all the way down the line. That's ordinal scale. Now getting into interval scales, this is where we start getting into scales that do have an equidistant space between them. So one example, an easy example, is a Likert scale. If you're not familiar with the term Likert scale, I'm sure you've heard someone say something to the effect of, rate your such and such on a scale of 1 to 10 or 1 to 5. That scale that you're using of 1 to 5, 1 to 10, those scales are called a Likert scale, like RT, but it's a name, so it's capital Likert, Likert. Likert scales are interval because they, one, are equidistant, so it's a 1, 2, 3, 4, 5. You know, you don't have a 1 and then the next choice is 4, and the next choice is 7, and the next choice is 25. It's all equidistant, so the space between 1 and 2 is the same space between 4 and 5, just 1. So these are all equidistant intervals between each value. And then there is no true zero. This can be a little complicated to think about, but think about this. So when you say, I find it's easiest to think of true zero as temperature. When you say that it's 0 degrees Fahrenheit outside, to say 0, that's not saying weather has ceased to exist outside or there is no temperature. We're in a temperature vacuum when we step outside. No, that 0 doesn't necessarily mean there is an absence of temperature. That is just an interval scale that we use where even though 0, it's more like a placeholder. 0 does represent something, and it's not the absence of temperature, but it just represents a pretty freaking cold temperature. However, Likert scales also follow this. So again, it doesn't have a true 0. You can have a Likert scale at 1 to 5. You can have a Likert scale at 0 to 4, as this example here shows. So when we look at this agreement scale, the top has a scale of 1 to 5, 1 being strongly disagree and 5 being strongly agree. Now the second Likert scale is saying, oh, it's an agreement scale from 0 to 4. However, it's the same number of points. It's still a 5-point Likert scale. One just happens to start at 1 and the other happens to start at 0. But they mean the exact same thing. If you were to complete a survey and do this on either score, you would still have a 1, or the lowest number is representative of strongly disagree, and the highest number is still representative of strongly disagree. The 0 doesn't matter because we can change it. You know, it can be a 1, it can be a 0. That doesn't really matter. So that's what it means to have no true 0. And I find it especially true with Likert scales because it's so easy to have it start at 0 to 4 or 1 to 5. It's still going to be the same: strongly disagree, somewhat disagree, neither disagree nor agree, somewhat agree, strongly agree. You can put that on a scale of 4 to frickin' 10 for all I care, 4 to 9. It doesn't matter. There's no true 0. These numbers, while we can use them to analyze it and do statistics, the numbers themselves are relatively arbitrary. They can really be set at any number, although typically we set it at 1 to something or 0 to something. You'll find that I'm more privy to starting scales at a 1 to whatever scale because I don't know, I just don't care much for starting scales at 0. But that's just me. That if you're a 0 to 4 kind of person, then you do you, boo. But you know, anyway. So ratio scales, as opposed to interval scales, they're the same in every sense, except 0 does mean something. 0 is not interchangeable with a 1 or with any other number. So some examples of this are height, weight, time, calories consumed. If I'm going to take a measurement and measure how many calories people consume in a day, 0 means something. 0 means you probably haven't eaten anything today. You're going to pass out. Eat something, please. But 0 means no calories were consumed, or the amount of time that passes. If you have a 0, that means no time has passed, or maybe number of hours or minutes you spend studying. A 0 means something. That means you did not study at all. Don't be that person, but that means you didn't study at all. If you're measuring, let's say you have kids and every month you take a pencil or something and mark their height on a door frame of some sort. Their height, their growth measurement, God, this is turning into a mess, but their measurement of growth, a 0 means something. If they have not grown at all between this month and the previous month, 0 means something. It's not like, ooh, I'm just gonna mix up this 0 with a 5. Ooh, they grew 5 inches. It's like, nah, little Jimmy is still pretty short, dude. He didn't have a growth spurt yet. So these numbers mean a 0 actually represents something with a ratio scale. So some more examples are here's some examples here. So crying time in minutes by people who are rich, by people who are in college or kids in preschool. You see here that if you say you have 0 time spent crying in minutes, so you've spent 0 minutes crying, this rich person, they did not cry at all. So that true 0 means the absence of crying. Same thing for plant growth in inches, or, you know, again, with your kids growing, if you have kids, or if you're doing a weight loss program and you maybe you weigh yourself on a week by week basis, and you have a 0 in terms of, well, I didn't gain any weight, but I didn't lose any weight, so my change in weight is at 0. Maybe it's at a -5, maybe you lost weight, maybe it's at a +5, maybe you gained weight. But a 0 in that sense means you stayed the same. You didn't gain weight, you didn't lose weight, but it means something. So I say group collaboration, but I guess more so talk to yourself or your roommates. So just think about the differences between the nominal, ordinal, interval, and ratio scales, and then what are characteristics of each of them, and provide an example. So again, I'm going to go into a little detail about this, explain the differences, just as a little recap. But I'm going to get right into it, so you can pause it right here. Okay, I just like making a silly thing, but now I'm going to explain. So by pausing the video, you guys can have time to, think about it. So the differences between these 4 scales of measurement is, again, nominal is more so an identification. Nominal you can kind of think of as name. It sounds similar to name. So nominal scales of measurement is more so just identification. So again, thinking of those credit card numbers or VINs or social security numbers, the number itself doesn't mean anything. Because when we think about interval and ratio scales, the number does represent something. It's the number of minutes you spent crying, or your scale of how much you like or how much you disagree or agree with something. Those numbers do represent something. They have meaning to them. But your social security number, the numbers themselves, they don't really do anything but identify you as Angela Cooper living in Fresno, California, blah, 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 blah. So that's nominal. It's kind of providing a name, for lack of a better term, a way to identify something. Ordinal, again, this is like an order. It's the order of people that either come into a race, or the order of most liked to least liked photos on Instagram, or what have you. The difference between ordinal, or the main point with ordinal, is that the spaces between first and second and third and fourth, etc., there don't necessarily have to be equal like they would for interval or ratio. They can be like the instance of the Instagram likes. About 54 million likes was number 1, and then almost 19 million likes was number 2. Well, there's a big difference. And then the third most liked photo was 18.4 likes, or million likes. So there's obviously not the same distance between the first and second and the second and third most liked photo on Instagram. So that would be an ordinal scale. With interval, think Likert scales. Honestly, that is the easiest example I can think of when it comes to interval scales of measurement. So this does not have a true 0, and they're equidistant. So you're going to have a 1 to 5 scale, and the scale goes from 1 to 2 to 2 to 3 to 3 to 4 to 4 to 5. Equidistant between all of them. There is not a scale, there's not a point in the scale where it jumps and makes like random jumps to random numbers, and then saying, oh yeah, rate your happiness on a scale of 1 to 72. 1 is super unhappy, 50 is kind of sort of happy, 52, it's not like a mess like that. It's all equidistant, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. Again, the main point with interval scales is that they have no true 0, at least in comparison to ratio scales. That 0, arbitrary. It's a placeholder for saying you strongly disagree with something, or that does not apply to you at all, or whatever your scale for your interval or for your Likert scale is, whatever it is that you're measuring, agreement, how often you do something, the frequency of something, or how much is this like you? I don't know. The lowest point is always going to be, whatever that lowest point is, be it strongly disagree, or maybe it's strongly agree, whatever that lowest point is, It can be represented by a 0 or a 1. It's interchangeable. It's still going to tell you the same thing. With ratio scale, we have a true 0. That 0 and 1 is not interchangeable. If you count the number of raises you get in a year using a ratio scale, hey, if you have 3 raises, if you get a raise 3 times in a year, that's cool. You don't want to interchange that with a 0. That definitely means something. To switch from a 0, from a 3 to a 0, it's like, wait, my raise, what the hell, my money. So ratio scales do have a true 0, where that 0 represents something true and concrete, and it actually has value as opposed to just interchangeable like it is for interval. So in terms of providing examples, I've kind of provided some new ones here, but I encourage you guys to think of new ones yourselves, just to ensure that you're kind of getting this idea. If you have any problems with it, if you're kind of getting confused between interval and ratio, or I find those two to be the biggest confusion for students, but any of these scales of measurement, don't hesitate to contact me. Canvas, email, office hours, I'm here. I'll answer your questions regarding these scales of measurement. So when we talk about statistics, when we talk about variables and ways to measure them in psychology and in statistics, we have those scales that we discussed of nominal, ordinal, interval, and ratio, but we also have more cut and dry things where it's a little clearer. And honestly, these variables that I'm going to be getting into, these distinctions between variables, is more so what we're going to be focusing on in this class, especially when we get into inferential statistics, where when we're looking at defining the relationship, DTRing our data, our relationships between one variable and the other. So to start, we have continuous and discrete variables. So these variables, any variable can fit into either one of these categories, be it how many bottles of shampoo you consume in a year. Well, like use, not consume makes it seem like you're chugging shampoo. I don't suggest that. Or what your average income is in a year, how many times the length of your favorite song, whatever, any variable that you have, they're going to likely fall into one of these two categories of types of variables, and those are continuous and discrete. So for continuous variables, as kind of indicated in the name of continuous, they're measured along a continuum, which essentially just boils down to it can include decimals. So if I am going to so the example I have here is the length of an ad on Spotify, assuming that you still have the patience to have Spotify without ads, or if you're like, dude, it's free. No judgment, I get you. But ultimately, the length of an ad on Spotify, let's say that you take a stopwatch or take your phone and turn on the stopwatch there and start it at the beginning of the ad, and then you end it right at, once the ad is concluded. You're going to probably have a decimal. Or if you measure a bunch of different ads, chances are you're going to get decimals. It's not going to be 29 seconds even. Maybe some ads are, but a lot of times they probably won't be. They're probably going to be 29.65 seconds or 30.52 seconds or something. It's not going to be, there's the possibility of it not being right on the dot when you use a stopwatch when you're measuring the length of an ad or a song or something like that. That would be an example of a continuous variable. It's along a continuum. There is space between 29 seconds and 30 seconds, and it's those milliseconds that you have in between. But you can stop your stopwatch and hit a decimal when you measure the length of time of an ad or of a song or what have you. So that's just an example of a continuous variable. The examples of a discrete variable they don't have decimals. They will not include decimals. These are measured in whole units or whole categories. So do you have premium Spotify? Yes or no. There's no yes 0.2 or no 0.9. It's just yes or no. Simple as that. So for discrete variables, you have a clear distinction between one and the other. There is no wiggle room in between like you have for continuous variables. There's no decimals when it comes to discrete variables. How many kids do you have? 2. It's not 2.5. You don't have 1.5 kids. Otherwise, dear God, what happened to the rest of Charlie or what have you? Essentially, you have whole numbers of kids. The number of kids that you have are hopefully a discrete variable. You have 0, 1, 2, what have you. You have the Von Trapp family, you got like 7 or 8, I don't know. Either way, regardless, that is a good example of a discrete variable. So probably the types of variable distinctions we're going to be talking about the most in this class is this one here, the difference between quantitative and categorical variables. So with quantitative, it is essentially using numerical units. So think quantitative, think part of that is numbers. And these can either be discrete or continuous. So like we mentioned before, you can have the number of kids you have. That is certainly a quantitative variable. That's the number of children that you have, 1, 2, 0. That's a discrete variable, again, hopefully. And then you can have a continuous variable for quantitative numbers, where you have the length of a song. You know, you have a stopwatch, it's 3 minutes and 16 seconds, 0.5, or, you know, in 5 milliseconds or something like that. I don't know. So you can have discrete or continuous variables for quantitative variables. Again, it's measured in numerical units. So one idea that I think of, a quick and easy method, maybe kind of quick and dirty, is for quantitative variables, you can find the average of it. So you can find the average. I can ask every student in the class, how many kids do you have? And it's like, oh, 0, oh, 5, oh, 2, oh, 1, oh, 0, da, da, da. I ask all of you how many kids that you have. And that is a discrete quantitative variable because, again, the number of kids you have is not on a continuum. You don't have part of a kid. Hopefully you have a whole kid or you have no kid. And I can take the average of how many kids everyone has across the board, and I can find the average of, oh, this class has an average of all the X amount of students in the class, there's an average of 2.6 kids or something. Now, averages are oftentimes going to be continuous, but the point of the matter is, even though it started as a discrete variable, with average, typically it can change into continuous because it has that decimal involved, 2.6. But it's an average of the 40, 50, 30, however many people you're taking an average of, it's the average of those people. So in comparison to quantitative variables, which again, quick and dirty, use numbers, you can find the average of. Categorical variables are vary by class. So these have categories, and these can only be discrete. So if I were to ask, oh, what music app do you use? Do you use Spotify, or do you prefer, I guess I should say. Do you use Spotify? Do you prefer Pandora? Do you prefer Apple Music? Or do you prefer a different route? Do you prefer an other, one that's not selected or one that is not present in the choices available? You can say, oh, I love Spotify, or damn, Apple Music is my shit. I don't know, whatever. You pick the one that best fits your favor, your, preferable choice. And that's a categorical variable. If I were to find, so here it's more of a tally. I'm counting up the number of people that prefer Spotify, counting up the number of people that prefer Pandora, Apple Music, and counting the number of people who don't really prefer any of these, maybe prefer something else or none at all. And categorical variables use more of like a count how many are in the group kind of technique. So it's the same thing of, if I were to ask how many of you guys in this class are psychology majors, how many of you are biology majors, chemistry majors, maybe business majors, kinesiology majors, whatever you guys are, that would be a categorical variable of the different majors. I'm not really finding the average of psychology majors in that instance. I'm just asking, yo, who's a psych major? Yo, whatever. But I'm not really finding the average of psychology. I'm not finding the average of biology. If I'm gonna ask how many people have blue eyes in the class, I'm not finding the average of blue or the average of brown. It's just, we have 10 people with blue eyes and 30 people with brown eyes, or whatever the case may be. Categorical variables, you are fitting in one category. So you either, will I listen to your Fire album on SoundCloud? Yes, maybe, no. You can't really check more than one box unless specified. Certain things you may have to check more than one box, or it may apply to you to check more than one box, for example, ethnicity. But for the most part, categorical variables, you only choose one, you are only placed in one group. So that is my lecture on measurement. Again, if you guys have any questions, don't hesitate to contact me through Canvas or email or during my office hours if you need more clarification. Again, the biggest takeaway I want you guys to take away from this lesson is the difference between categorical and quantitative variables. As we move forward in the semester, it's going to be important that you're able to distinguish those two from another. It's important that I can provide you examples and you're able to think to yourself, oh, that's a quantitative variable, or oh, that's a categorical variable. And we can have the same variable, but it can be measured different ways. So for example, I'm just going to, let me go on this quick rant and then I'll finish it, then I'll conclude the video. So think about the variable of age, okay? You have, if I were to ask you, how old are you? And you provide me a number, you know, of how old you are. Oh, I'm 21, I'm 30, I'm 19, I'm whatever. That would be a quantitative measurement of age. I'm simply asking you to provide me your age and boom, I get it. You know, I just get the total number, or I get everyone's age, and then I can find the average and say, oh, the average age for this class is 24.2 or whatever, I don't know. If I were to measure age categorically, I would say, okay, who in this class falls between the ages of 18 to 21? Who in this class falls between the ages of 22 to 25, etc. Again, it's the same variable of age, but it's measured in different ways to make it either quantitative, where I can find the average by just adding all your ages together and dividing by however many there are, or I can measure it categorically by just kind of, you know, pick the group that you fall into. Are you between 18 and 22? Boom, you're right here, or whatever the groups are, doesn't matter. So it's important to distinguish, yes, you know, not only to know the difference between categorical and quantitative variables, but also keep in mind that the same variable can be measured in different ways. And you need to be able to know, oh, this, you know, when I ask for age groups, I'm measuring age categorically. Although more typically we tend to measure age quantitatively just by saying, hey, how old are you? But know that it can be done in other ways. So that's my little short spiel. That is the lesson for today. I hope it was beneficial. Again, if you have any questions, just contact me. I'll be happy to clear them up for you. And I hope you guys have a great day. And that's all, folks. Like and subscribe, again, if you're so inclined.